In this topic, we are going to learn about radian. Just like degrees, radian is the units that we can use for the measurement of angles. And the conversion between degrees and radian is given by 180 degrees is equals to pi radian, which will give us the conversion rates between degrees and radian. So, how many radian is 90 degrees? We will always start off with this conversion rate here, and therefore we will divide by 2 to give us 90 degrees equals to pi over 2 radian. What about 360 degrees? Starting with this conversion rate again, we will need to multiply by 2, and we will have 360 degrees equals to 2 pi radian. Since the pi value is approximately equals to 3.142, 180 degrees is approximately 3.142 radian. 90 degrees will be approximately 1.571 radian, and 360 degrees will be 2 multiplied by this to give us 6.284 radian. You'll notice that the value for degrees is much higher than the value for radian. Let's express 40 degrees in radian. We will always start off with this conversion rate, 180 degrees equals to pi radian, to convert between degrees and radian. To find 40 degrees, we will first need to find 1 degree. To do so, we will divide by 180 degrees. Likewise, on the right hand side, we will also divide by 180 to give us pi over 180. Therefore, to find 40 degrees, we will now need to multiply by 40 on both sides to give us pi over 180 times 40 radian. And this will give us 2 pi over 9 radian, or you can write it as 0.698 radian rounded off to 3 significant figures because pi here is approximately 3.142. Next, let us express 128 degrees in radian. To find 128 degrees in radian, we will first need to find 1 degree, and we will divide 180 on both sides. And we will have pi over 180 radian for 1 degree. To find 128 degrees, we will multiply 128 on both sides. And this will give us pi over 180 times 128 to give us 2.23 radian rounded off to 3 significant figures. Once again, do note that the value of degree is usually much greater than the value for radian. To convert 14 degrees to radian, we will first need to find 1 degree, and to find 14 degrees, we will need to multiply 14 on both sides, which will give us pi over 180 times 14. And 14 degrees will be equals to 0.244 radian, rounded off to 3 significant figures. Next, we will express 2 radians in degrees. Once again, we will use the conversion rate pi radian equals to 180 degrees. To find 2 radian, we will first need to find 1 radian. To do so, we will divide by pi on both sides. And to find 2 radian, we will next need to multiply 2 on both sides. By using the calculator, we will have 114.6 degrees rounded off to 1 decimal place. And therefore, 2 radian will be equals to 114.6 degrees. Next, we will express 0.854 radian in degrees. We will start off with the conversion rate pi radian equals to 180 degrees. First, we need to find 1 radian by dividing by pi on both sides. And to find 0.854 radian, we will multiply 0.854 on both sides to give us 48.9 degrees. Therefore, 0.854 radian is equals to 48.9 degrees rounded off to 1 decimal place. Next, we will look at how to use the calculator when we evaluate trigonometry questions that are given in radian. For instance, we are asked to evaluate sine 1.53. Whenever the unit is not given for the angle, it will be taken to mean that it is in radian. First, we will need to change the degree mode into radian mode by pressing this button here. For some calculator models, you need to first press the shift button followed by the setup button. After which you can press the number that can give you the radian mode. In some calculator, you just need to press the mode button and you can find the radian mode as well. After you have located the radian mode, the calculator will show the letters RAD to indicate that the angle is in radian. To evaluate sine 1.53, you simply need to press sine 1.53, and when you press equal, it will be equals to 0.999, rounded off to 3 significant figures. Now to recall, sine 1.53, which is equals to 0.999, is a trigonometric ratio. Now, if cosine theta is equals to 0.123, how do we find theta in radian? To do so, we will once again need to ensure that the calculator is in radian mode because we want to find the angle in radian. We will need to inverse cosine on both sides to give us theta equals to the inverse cosine of 0.123. This in turn will give us 1.45 radian rounded off to 3 significant figures. The angle is in radian because the calculator is also in radian mode. If the calculator is in degree mode, we will find the angle in degrees. So, using the same question, if the calculator is in degree mode, the answer will be 82.9 degrees rounded off to 1 decimal place, instead of the 1.45 radian found previously. In summary, the conversion rate between degrees and radian is 180 degrees equals to pi radian. Given questions that involve sine theta, cosine theta, or tangent theta, we will need to ensure that the calculator is in radian mode if the given angle is in radian, or we want to find the angle in radian. If the angle is in degree, then we will leave the calculator in degree mode. Therefore, if theta here is in radian, we will use radian mode, and if theta here is in degree, we will use degree mode. And that's all for this topic.